Hey guys, my name is Daniel Ahn, and I'm gonna talk about query segmentation technique using N corpus. So what is segmentation? So it is basically dividing user query into meaningful phases. So consider the following query: New York Times square dance. So you can divide it into New York Times and square dance versus New York and Times Square dance, right? So what's on the left is shown on the right actually in the picture. What's on the right is shown on the left in the picture. So potential benefit of doing query segmentation. So you will see some improvement on search performance. So for precision, because you can do exact queries match on identified phrases or segments, you will get higher precision. For recall, because you can do query expansion or substitution on the identified segments, so you can possibly get higher recall, and you can do some disambiguation. Because most of web searches do not include the quotes, so the meanings are confusing, as you saw in the last slide. And then kind of similar on similar note, you can understand query intent better, then which kind of leads to like better query suggestion on query completion. So let's define the problem a little better for the scope of this project. So we want to do automatic pre-retrieval query segmentation, which means we want to segment the query before we submitting the query, so that we can enjoy all the benefit that I described in the previous slide. So in other words, given a keyword query, identify the best segmentation in real time while there's no other user signals available. This is the assumption I'm making. So these are some related work. There are some technique called like mutual information, supervised learning, unsupervised learning, deep learning. So basically machine learning techniques, and corpus statistic one. That's the one I'm gonna focus. Is mostly work by Hagen and al. So I'm gonna review the first paper that I mentioned in the previous slide, SIG-IR 2010 paper, power of naive query segmentation. So there are several steps to compute the segments. It's based on corpus statistics. So step one, let me try to describe it, right? So step one is fetching n-gram frequencies of potential segments. So this example is segmenting New York Times Square. That's our favorite example. And then for potential words or phrases or segments, it gets the frequency from n-gram corpus. So you can see that New York is more frequent than New York Times Square, which kind of makes sense, right? Step two is you're normalizing the frequency, because usually longer phrases appear less, but longer phrases are actually more valuable because they're valid phrases. So you multiply it by the length of S, which is segment. Basically, like length of New York is 2 because it's 2 gram, powered by the length again. So for New York, for example, you're multiplying it by 2 to the power of 2, so 4. So this number times 4 equals to the weight here, right? So each segment basically gets weight. And then step 3 is score every segmentation S. So the uppercase S is a set of segments that defines segmentation, right, of a user query. So this is a example segmentation, and then we computed different weights in the previous slide for each segment candidates, right? So by simply adding them for the segments that are longer than 1, so from 2 grams, right, you can compute the score. And then as a last step, basically these are the potential segments or segmentation, sorry, of the user query, and then you sort it by the score you compute it, and then select the top segmentation from the score ranking. So for the data set, so I'm actually reviewing their next paper, World Wide Web 2011 paper, query segmentation revisited, right? This is a AOL log, which has about 53,000 web queries, but segmented by manually by crowdsourcing. But then unfortunately the public version only has sample query like about 10%, 4,800 queries. So this is how it looks. This is a query ID, and for this query, Northern Star Financial Inc. 5 people kind of segmented this whole query as a single segment. So that's, and then 2 people segmented all tokens as a separate segment, right? So that's why you see pipe character. And then 1 person segmented this with 3 different segments. Northern Star is a segment, financial, and Inc is a separate segment, right? So and so on. This is how it goes. And then 5 plus 2 plus 1 plus 1 plus 1 adds up to 10. And then this is their result in 2011 paper. So annotator is best of AMT, meaning they took the best vote from the crowdsourced segmentation data. Then MI means another algorithm, mutual information based algorithm. And number 10 is basically the naive query segmentation algorithm that I show you guys in slide 7 through 10. And our means Wikipedia augmented version of number 10. So you can see that it got about like 60% of the segmentation right, which is not too bad, I guess. And then for the rows, for performance measure, I think I need to expand on this a little bit. So let's say this is the reference, basically like the manually labeled segments. And then this is the computed or predicted segments. So this has 3 segments, reference has 2 segments. So for query accuracy, because their segments doesn't really match, 0. And for precision, out of 3 computed segments, 1 is correct, so it's 1 out of 3. And then for recall, out of 2 reference segments, 1 is found, right? New York Times is found. And then for break accuracy, so there are actually 4 different spots you can basically break, right? Like between you and York, any space, York and Times, and so on. And then you can see that 3 out of 4 we got it right, like between you and York, York and Times and Square, we got it all right. But the last one, right? So break accuracy is kind of measuring whether we divided the segments right or right. So one more thing on their paper. So they actually use Google 2006 Ngram dataset. Some characteristic. It has around 1 trillion word tokens from public web pages, and then it's also known as 1 trillion 5-gram version 1, and it has size of 24 gigabyte compressed, so which is pretty big to fit in memory. And then with Zipf's law, they're including engrams that has occurrence frequency that's greater or equal to 40. So that was their paper, but my experiment goal is, with Zipf's law, I want to check whether we need all trillion words. 24 gigabyte is pretty large, right? How do you, put it into web server and serve it like pre-retrieval time, right? So can you achieve comparable result with much smaller corpus? So experiment design, we should note that the 06 ngram is not free, and there's no public access to WebSQSec10 data either. So I created a new baseline with the public version of it with Google Book Ngram version 2, which is a 2012 version of Google Ngram. And then I tried to run segmentation with much smaller COCA corpus, which is corpus of contemporary American English. It has 520 million words, and then 70 megabytes after uncompressed. And then Google Ngram can be searched from this website. So this is implementation details. It only took like 0.61 seconds to segment these many queries. So this is the result. COCA. So let's focus on query accuracy, right? So it had 22% of segmentation right, whereas Google Book one has 345% or 34% right of the time, right? And some improvement I made was I observed that n-gram that starts or ends with stop words do not usually form a complete phrase, so remove them from n-gram corpus. So I was able to see some bump for Google Book especially after removing stop word from corpus. So as a last slide, Coca seems much worse than 2006 Google Web n-gram. So about like 30%, 35% different. But I don't think it's a fair comparison because Coca only ran on the part of the data set, and the percent difference is 60% decrease in accuracy. But we should also note that the number of n-gram decreased by 99.95%, like 1 trillion to a few million. And we should also note that Coca is worse than Google Book, baseline as well, right? But Google Book baseline is much larger than, or Google Book corpus is much larger than 2006 Google Web n-gram. So can you conclude Coca corpus is too small? I think this is too early to conclude. So before I submit the final paper, I wanna focus on augmenting the result with the corpus with Wikipedia dataset, and also augmenting the algorithm with Coca POS label dataset, which is publicly available. And then I want to explore improvement on the algorithm for higher accuracy. These are the citation for your use, and then please visit my repo.